Have you ever wanted to terrorize some villagers with the Ender Dragon, but on bringing it into the overworld, you found that it just does donuts? Also, it seems a lot smaller here than in the end. So today, we're gonna build a bigger one! You could say this dragon's not gonna be built to scale, because dragons have scales. I'm really winging it today, but I know this video is going to be a roaring success. Don't stop me now. I'm clawing it back. Okay, enough. Let's not let this segment drag on. On with the video. Oh boy, this dragon is going to be big. This dragon is nearly as big as this village. It is going to be massive. I may have gone a little overboard. I wanted to sketch out this skeleton, and yes, I know this is not what a skeleton would actually look like because, well, A, it reminds me of Skyrim, and B, I wanted to lay out roughly what we are going to do with this dragon today. We have the head up here, and I want that to breathe fire, obviously, and then we've got a little neck section. I've put these segments in to represent the idea that we're going to have lots of different joints so that the neck can bend. The same with the tail. The tail is going to be even longer, so it's going to have a little bit more flick to it, hopefully. We definitely want to do something with our legs. They definitely going to need to be a better shape than this. They look very goofy as is. I think they're going to be fairly basic today. They're probably just going to go from this position upwards into a flight position. I've made the body nice and big. It's going to need to fit all of our redstone controls and our mechanical controls for the wings and the tail and the head. The big thing that is missing is the wings, and I think the wings are going to need to be at least as long as the body on each side to really give us that like scale of a big scary dragon. A dragon that is going to need a name. So get in the comments. You can't have an existing one like Smaug or Rhaegal, one of those ones from Game of Thrones. Now we've covered the bare bones, I have a question for you. Heads or tails? It looks like a duck. I know. We're working on it. It'll get there. Give it time. These are our heads and tail mechanisms. As you can see behind me, I'm using a lot of ropes, and down on the tail end, we're using a lot of springs. Each of these segments in the tail is held together by some rope across the top and some springs across the bottom, and is actually connected by a swivel bearing that is unlocked. To avoid unwanted collisions between this segment and this segment, for example, I'm actually using ghost blocks as the main connection points from our swivel to the next segment. The ghost block is added by Copycats Plus, and crucially has no collision with entities. With all of the swivel bearings unlocked, you can see that the tail now has a little bit of droop in it. My original plan was to take an animatronic approach to this dragon. I originally tried pulling ropes backwards and forwards to create a little bit of motion in the head and tail, and eventually settled on another swivel bearing that rotates the entirety of the first segment, allowing that motion to travel through all the sections. There was a little bit of an issue, however. When I first tried to get the dragon off the ground, the neck and tail joints were so loose that the force of the flapping wings were throwing them everywhere, and the whole dragon became, well, very floppy, which is not a good look for a dragon, I don't think. Oh, that's not good. You're supposed to be the other way up, come on. Oh, this tail is a mess. Back to the drawing board, I guess. Parthenax, that's a good dragon name. Can't have that one either. To fix our flopping issue, I've added a little bit of levitite to the head and the very last segment of the tail. And what I think I'm going to do is lock the first segment on the swivel bearing so that it's not loose like this and is in fact still rigid, and only unlock the last two segments here. And I think with the tail, we're actually going to remove all the springs. The springs are really loose, and we're going to replace those with more ropes. I've also decided to repurpose our animation system. Instead of the torsion spring rocking backwards and forwards on a loop, I'm going to hand over control to the player. So for the head, we're going to be able to move up and down. You can see if I hit this lever, the head starts going down and it's just hit the floor, but as it comes back up, we can see those joints working to move the head, and it just gives it that little bit of life. And then for the tail, instead of going up and down, we're actually going to go left and right. If I hit this lever, oh, that was a little quick. Turn that down. These need to work very slowly. What I'm hoping is that we can use our up-down head motion and our left-right tail motion to actually steer our dragon. You'll notice that because of the way our swivel bearings are oriented along the tail doesn't really bend when it moves left and right. Normally, an animal's tail would actually swish, and those segments would actually move. I did try and put a second swivel bearing on each segment, but I'm finding that these swivel bearings, they don't hold very much weight, especially when you use them in conjunction with each other for multiple axes movement. What are you doing? I don't know if I'm doing something incorrectly. They seem to work fine if it's a lightweight, or I guess if there's less forces acting. Please let me know if anybody knows how to strengthen these. If you were able to strengthen them with an analog signal, that would be very cool. Like controlling the level of friction of the swivel. But for now, I think we're going to have to stick to one axis of movement for the tail and the head and the wings. And I think that's probably a good thing given how floppy the dragon was earlier. I think we need a little bit of rigidity to make sure that this thing actually flies. You may have already noticed some redstone in the head and this little dispenser. You guessed it. That's how this dragon is going to breathe fire. So if we go over here and we press this little button, that was a little underwhelming. Let's try that again. Okay, round 2. Oh, that was way cooler. Oh, that was so good. We've got a dragon that breathes fire. Speaking of hot stuff, let's give this dragon some legs. I was goofing around testing out the fire breathing and I nearly burned this cat to death. Sorry, buddy. But our legs are now done. And they do still look a little goofy at the bottom because we're not really focusing on walking today and we want to get this thing flying. I've just opted to put grindstones on the bottom. Grindstones are slippery, so they'll functionally act like wheels. And the proportions of these legs look much, much better. I think they are a lot more in keeping with the size of the dragon now. And they're all connected up to these swivel bearings, which is going to allow us to tuck them up when we're flying into a sort of flight mode, as if the dragon was a little bit more aerodynamic. It doesn't really make any difference, but I think the look of it will be cool. We just need to hook them up to a sequence gear shift that's going to control that rotation. And all we need our sequence gear shift to do is turn forwards by a small angle and then wait for a new redstone pulse and turn back by the same angle. Really simple. Let's give that a go. Okay. I had that set up all wrong. The rotation was going into the back of the swivel bearing. Just need to put some gearboxes and cogs on the side of the swivel bearing. And now let's try that again. Interesting. Ooh. There we go. It's not like this was supposed to be the easiest part of the video. Nice aerodynamic flight position. This is looking very streamlined now with the tail and the neck all locked. Not going to be like that for the real thing. The other thing to consider with the legs is that, well, they are quite heavy. That's the weight of one leg. It's nearly 40 kilos, which means that all 4 of them together is 150 odd kilos. That is a lot of weight. So it might be best to employ the other property of the ghost block, which is that they actually don't weigh anything. So I think we're going to have to replace quite a lot of the blocks in the leg and maybe leave a few blocks as physical blocks that will act as like a hitbox for the dragon so that it can actually still collide with things. If we were to do something like this, you can see that it drastically reduces the weight. That's a huge difference. With our ghost block swapped in and our legs working, it's time for the bit we've all been waiting for, the wings. I couldn't help myself. I've already decorated the wings. These things are huge. They're 2-segmented and they're held together by a very similar system to what we have going on in the neck and tail. As you can see behind me, there's a swivel bearing with some rope on either end just to hold the wing together and give it some stability. And in the middle, we have these ghost blocks. We'll get to the redstone that's going on with these bearings in a little minute, but as you can see, there is just a little droop in the wing, and when that wing is moving up and down, that's going to allow this second section to fling out up and down. But the wings are currently not actually hooked up to anything, so let me put all the mechanics in that are going to make these things work, and then we can talk about how they are actually going to flap. Oh, we got a dragon on our hands, ladies and gentlemen. Oh, I'm in the fire. Look at these things. Ah, it's so nice. Let's talk about how they work. First up, very simple on and off switch. Torsion springs work really well here because when we turn off our flapping mode, they automatically revert to neutral, which puts our dragon into a kind of gliding mode. This system here is controlling our flapping, and all that's really happening is when we hit the start, we put rotation through in a certain direction that causes our wings to go up. The torsion spring that's rotating the wings is being monitored by comparators, and when that comparator outputs a signal, our rotational direction is reversed, so the wing goes back down. This also allows us to modify the rotation range of the wings. Currently I have it set to be a fixed amount, and when we go up slightly higher than when we come down. That's to stop us from hitting the floor when we're flapping near the ground. On each side of the circuit, there's also a little control that adjusts the speed of the wings, so when we're going up, we're going slightly slower, and when we're going down, we flap slightly faster to generate more lift. To increase the efficiency of the wings even further, I thought I'd try and mimic how birds fly. So I designed a little circuit that allows us to lock our wings at certain points in the rotation. As the wing reaches the top of its rotation, the outer segment flicks upwards, and I wanted to lock the wing in that position in order to generate the maximum lift on the down thrust. The wing then unlocks so that the outer segment folds on the way back up, generating less lift. And the way we do this is with the directional linked receiver. This is paired with a redstone link on the other segment of the wing, which provides us with an analog signal strength that represents how in line those two segments are. Anytime that signal strength goes above 13, the swivel bearing at the front of the wing gets powered unless the wing is going upwards. And I think that's resulted in a really quite natural looking wing flap. It looks really nice, and hopefully it actually generates a decent amount of lift in the right direction. I'm so excited to see this thing fly. But before we can get this thing in the air, there's one last little thing I want to do with this circuit. You might have noticed that it's duplicated on either side. We could just control both wings through the same torsion spring, but I've duplicated it to allow us to control each wing's speed individually, and that's going to help us stabilize the dragon. If it tips one way, the lower wing is going to flap faster and the upper wing is going to flap slower, and I'm hoping that will slowly right the dragon and keep it level. And I think the way that we can do this is actually really simple. I think all we need to do is put analog transmissions here and here, and then we can just put a gimbal sensor in the middle. Now, if our dragon tips to the left or the right, that gimbal sensor is going to output a signal to the lower side, and the analog transmission is going to speed up that wing, hopefully generating more lift and righting the dragon. Now we have pretty much everything we need to make this dragon functional. We need to connect all of those systems up inside the body, make them survival friendly, and put the redstone in there. And I need to get off this wing because it is making me feel sick. These wings generate a lot of lift, but they're still not powerful enough to keep our dragon in the air. We could make them bigger and faster, but we're not making a bird, we're making a dragon. And all the best dragons have just a little bit of magic about them. What are your guys' favorite dragons, by the way? Mine are probably the dragons from Earthsea. I love Yvord and Ormembar. Anyway, the magic that powers our dragon today are these two propellers, and I guess also these 4 engines. Let's give these engines a little bit of power. We do need them all to be superheated to generate enough stress to power our propellers. They are using about 5,000 stress each, and they are generating a whole ton of thrust. Oh, I love how these sound, they're so cool. You might also notice that they're attached to a swivel bearing, and that is to allow us to turn the propellers, which we're using to help aid our tail in turning left and right. There is a whole lot of spaghetti cogs here into analog transmissions that we're using to slow and speed up various different parts of the machine. We want obviously our head and our tail running nice and slowly. The propellers are running really fast. And the wings flap at about 8 RPM as the base, I think, and then they obviously get modified depending on what our gimbal is doing and which side is supposed to be flapping faster. With all of this stuff in, our center of mass ends up being somewhere around this cog here, which is great for the lift of the wings. That's being generated kind of in the center of the wings here, so that's roughly in line. But it is a little unfortunate that our propellers are sitting quite high, so I'm going to do a little bit of rebalancing as best I can. I think I want to take a lot of the weight out of the tail and out of the head using more ghost blocks, and then we'll take this thing for a little test flight. Just going to add a couple of finishing touches. Oh, this dragon is really coming together. I am excited to give this thing a test flight. Let's give it a go. And... oh, we're off. We're going up. Oh, and glide. Oh, look at this. Look at this guy. You can see our wing stabilization at work here. We're ever so slightly off angle, and over time we are going to right ourselves. See how the dragon does. It does take a little bit of time. There we go. You can see the analog transmissions are slowly starting to come back into line, both going off, which means that we're pretty much level. It's never going to be completely level, but it does work really well. We have kept very stable. We're able to turn without tipping over to the side. And another thing that I have noticed is that whilst the wings can get a little bit out of sync like this, all you have to do is go back into our gliding position and that resets them, which is really, really handy. It does also seem much better to go into a glide from the wings in the upright position. It looks more natural as an animation, but also it tends to mean the wings are locked for the gliding position, which generates a lot more lift and keeps you a lot more stable. However, if you do want to descend, you can lock the wings like this with the outer segments slightly lower, and you're going to start to lose altitude very quickly. I think I might be becoming a professional dragon rider. Oh, I'm so happy with it. What is our turning circle like? That trail of fire is where we came from. Let's see if we can do a full 360. Turn, come on, turn. The turning circle is not great, obviously. It's a pretty big dragon. To get this thing to fly a little better, I've made a few more adjustments to the balance. I've actually taken most of the levitite out of the head, you can see there, and I've strengthened up the tail and the head joints a little bit with some rope winches. And look at this thing, it's flying so nicely. Again, the turning circle, really massive. Still can't see that fire trail just yet. Oh, let's have a go at burning this village, eh? Okay, in we come. 3, 2, 1, fire! Oh, what? Where did all the fire go? So our fire breathing doesn't seem to be working very well, but maybe we can fix that. What are we going to do about our fire breathing? As you can see, it still works when we're on the ground, and that's because we're not moving. I think the problem is that fire charges don't move very quickly. And so when the dragon is flying, it actually flies quite quickly, and the fire charges are getting stuck in the head. As you can see here, the head is currently on fire. I know I always say I don't like to add too many mods, but this dragon has to breathe fire. That's a non-negotiable. And I know that Create Diesel Generators, or I think it's the Factory Must Grow, adds this chemical turret, which I'm hoping is going to allow us to spray some fire properly. Our chemical sprayer is installed. Let's give this thing a try. Oh, it looks cool. This is going to do some damage. Oh, yeah. That's perfect. Look at that. Oh, amazing. It's finally time to decorate this dragon, which is probably going to ruin all of the balancing that I've done for the past 3 hours, but I cannot wait to have a big, scaly, scary dragon. I have gotten very attached to this mechanical framework that we've been working with, but it's really not going to be intimidating enough to terrorize a villager. We have our large, scary, and largely incorporeal dragon. Boy, do I think it's worth it. This thing looks so cool. I really, really like how it's turned out. I love the mouth. It looks terrifying. And I've added quite a lot of extra texture that the Ender Dragon doesn't have. It's obviously got like a lighter underbelly and neck, but I'm really, really happy with how this looks. I'm very, very excited to get this flying. I'm probably going to have to rebalance all sorts of things because all of the weight distribution has changed where I've put extra copycats on. And I think now is a good time to mention how we're going to get this thing to fly high enough to work in survival. You have to remember that in super flat, we're currently sat basically at bedrock. My Y level currently is very, very low, which means that our dragon wouldn't function at a regular overworld air pressure. However, luckily, we can take advantage of the Aeronautics lift patch, which changes the way that Aeronautics wings work. You see, in regular Aeronautics, the wings scale linearly, whereas the lift patch allows us to scale the wings lift quadratically, meaning that bigger wings generate a lot more lift. And the difference is stark. In super flat, we were flying at about Y50. Here we're flying at about Y level 250. And that's without even flapping the wings. We can reach 300 easily. And hey, the turning circle is not bad either. I'm getting really good at finding that balance point between tipping into the turn and going so far that the wings stop working. I kind of love how, like, rattly and jerky the motions of the dragon are when it's flapping. It feels simultaneously mechanical and alive, which I really like this. I could spend hours just flying around on this dragon. It is so much fun to just be soaring above the terrain. I think it is about time we go find some villages to terrorize. Just have to actually find a village. I haven't seen any so far since I came into this world. Okay, there's one. We're coming in for a bombing run. 3, 2, 1. Oh, that was rubbish. I didn't even hit the village. Okay, this is going to take some practice. It's a good thing that this is a lot of fun. Okay, so I might not be the greatest dragon rider of all time, but I gave it a good go. I got a couple of shots onto the village, or at least close to one. And to be honest, I don't really care. I'm having so much fun. If you would also like to try this dragon, the schematic will be available. The code this time is the name of a famous dragon. It's not one of the ones I've mentioned in the video, but they might provide you with a clue. A huge thank you to all of our members for making these videos possible. If you've enjoyed this video, please give it a like, comment your ideas for other things we can build with either Just Create or Aeronautics, subscribe if you're new and you want to see more of this kind of thing, and I will see you next time.
Just keep swimming, just keep swimming, just keep swimming, swimming, swimming.